Welcome to my YouTube channel. Today we are going to learn about the principle of relativity and something about Newtonian gravity. So principle of relativity tells that if we perform any identical experiment in two different inertial frame, the outcome will be the same. So suppose this is the inertial frame 1. This is the inertial frame 2. IR1, IR2. The coordinate will be x, y, j and x dash, y dash, z dash. So if we perform any identical experiment in these two inertial frame, the result will be the same. Suppose if there is a particle in this inertial frame, free particle, and its coordinate are x, y, z, and it is moving with constant velocity, then the equation of motion of this free particle will be d2x by dt2 will be 0, d2y by dt2 will be 0 and d2z by dt2 will be 0. It means the acceleration component of this free particle in this inertial frame 1 will be 0. Now let us analyze the motion of this free particle in this inertial reference frame 2. So the coordinate of the inertial reference frame 2 will be x dash will be x minus d, y dash will be y, z dash will be z. If we differentiate these three equations with respect to t 2 times, then we will get d2x dash divided by dt2 will be 0, and again d2y dash divided by dt2 will be 0, and d2z dash by dt2 will be 0. It means acceleration of the free particle in the second inertial frame will also be 0. So the equation of motion will be identical in both these inertial frame. And what about line element? The line element in this inertial frame 1 will be ds2 will be dx2 plus dy2 plus dz2. What is line element? Line element is distance between two close points A and B. This is line element ds. So ds will be dx square dy square plus dz square. Suppose there is another inertial frame x dash, y dash and z dash which is rotating about the origin O. In that case, what will be the line element? So the coordinate will be x cos phi x dash minus sin phi y dash, and y will be sin phi x dash plus cos phi y dash, and z will be z dash. So this inertial frame 2 is rotating about the z axis, this axis. So z and z dash will be identical. In this case, what will be the line element? The line element will be dx square will be dx square plus dy square plus dz square. So we have to square these three things and put into this equation A. And if we cancel out these terms, we will get dx dash square plus dy dash square plus dz dash square. This is the line element in the inertial frame 2. which is rotating about the z axis, and we can see that line element A and line element B is identical. It means ds square is equal to ds dash square. So the distance between 2 points will be the same in all inertial frame. So this is the little introduction of the principle of relativity. According to Newton's law of gravitation, the gravitational force Fg exerted by mass m on small mass m will be minus g m by r square er, where er is unit vector F gravitational. We can write this formula in terms of gravitational potential minus m del phi xb, where phi xb is the gravitational potential generated by this mass m. So gravitational potential generated by mass A is minus g m divided by r square. So we can write gravitational force in terms of gravitational potential minus g m by r, or we can write g m divided by x minus x b. X minus x b or x a is distance from the origin, or we can also write this gravitational potential in terms of sum of the masses, g m divided by x minus x a. Gm divided by x minus x a. If we take all volume element dqx and its mass density is mu x, then we can write this one in terms of volume element density or mass density, which will be phi x is equal to mu x dqx divided by x minus x dash. This is the this is the gravitational potential in terms of integral g mu x dqx divided by x minus x dash. X minus x dash is the distance from the origin, and according to this one, F gravitational force is equal to m delta x phi x b. We also know that F is equal to mg, m delta phi x b, or g gravitational acceleration is minus del phi x b. This is the gravitational acceleration, which is minus del phi x b. Or if we take del dot g, it will become minus 4 pi g mu x. So this is the formula for gravitational acceleration. So this is Newtonian gravitational field. Newtonian gravitational field. Del dot G is equal to minus 4 pi G mu x, where mu x is the mass density, G is the gravitational constant. We have calculated Newtonian gravitational field Gx is equal to minus del phi x. Phi x is gravitational potential, and also we know that del dot Gx is equal to minus 4 pi G mu x. If we put this value of this Gx into this one, we will get Laplace operator phi x is equal to 4 pi G mu x, and this one is identical to Poisson equation in electrostatic, in which in Poisson equation of electrostatic, in the electrostatic phi x is simply rho electric divided by epsilon naught. This is for the electric field. This phi x is electrostatic potential. So these two things are nearly identical. So there is some similarity between electrostatic and Newtonian gravity. Newtonian gravity, electrostatic. The gravitational force in Newtonian gravity is minus Gm m divided by r square, and in case of electrostatic, the electric force is minus plus q 4 pi epsilon naught r square. So both these force, gravitational force and electrostatic force, is inversely proportional to the square of the distance. And the force in terms of potential will be minus m del phi x b. This is in case of gravitational force. In case of electrostatic force, it will be minus q del phi x. This is potential, electric potential. So again, both these terms are identical. If we write the force in terms of potential, again potential outside a spherical source, it means the potential outside a spherical source will be minus Gm divided by r. And again, in case of electrostatic force, electrostatic potential is equal to q divided by 4 pi epsilon naught r. This is the potential outside any spherical source. Again, the field equation for this gravitational, in case of Newton's law of gravitational, is epsilon Laplace operator phi 4 pi G mu x. This is in case of Newtonian gravity, and this is the field equation for the potential, and field equation for the electrostatic potential is electric divided by rho electric charge density divided by epsilon naught. So these are the identical thing in Newtonian gravity and electrostatic in electromagnetism. There is a Newton's theorem which tells that the gravitational field outside any spherical symmetric shape is only depend upon its mass. So how we calculate the gravitational field outside any spherical surface? So we have calculated the gravitational field is equal to minus 4 pi G mu x. If we integrate these two terms in the surface dxq, then we will get dqx g is equal to minus 4 pi g dqx mu x, and this one is nothing but a total mass. So minus 4 pi g m, and this one, this is the total surface, and total surface will become 4 pi r square g. This term is the total surface, 4 pi r square g, total surface of the spherical surface. 4 pi r square g is equal to minus 4 pi g m, or g is equal to minus g m divided by r square, minus g m divided by r square, gr, or phi gravitational potential is gm divided by r, minus gm divided by r. So Newton's theorem tells that gravitational field outside any spherical surface only depend upon the total mass of this spherical surface. G is equal to gm by r square. We have calculated the gravitational acceleration is equal to gm divided by r square, and we can use this equation to derive Kepler's law. Suppose there is a mass which is in the circular orbit of radius r and period is p, and the centripetal acceleration on this mass will be v square by r, which is identical to gm by r square. This is the centripetal acceleration, and this one is the gravitational acceleration. And we know that the velocity of that mass in the circular orbit will be 2 pi r divided by period, time period p. So 2 pi r divided by time period p to the whole square divided by r equal to g m divided by r square, or this one is big R, not small r, or p square is equal to 4 pi square divided by gm r cube. Now we can see that the time period p is proportional to the cube of the semi major axis r cube. So square of the time period is proportional to the cube of the semi major axis r. So this is the Kepler's law. So we can use the gravitational formula for gravitational acceleration g is equal to gm by r square to derive Kepler's law.